This is an example calculation to determine the maximum profit. We have shown this in the earlier videos, how to find the maximum profit applying the calculus method. However, in that situation, we assume that the price changes linearly based on the demand. So if the demand increases, price linearly drops like that. So it was a linear equation. However, as you can see here, the price relationship is not linear with the demand in this case. So what do you do? First of all the formulas we have developed using this straight line relationship does not apply. However, the basic method, the way we have developed this formula, stays the same. So whenever you have these different kinds of price relationship, you'll have to apply the basic methods. So let me kind of go through this again. So it's going to be a second example of how to basically apply calculus to solve these problems. So total cost was the fixed cost was given 300, and then the unit cost was given 150. So the total revenue now this time is going to be the price plus times the demand. So this is the price in this case, not a straight line, it's a curve, second degree curve, times the demand, like that. So the total profit would be simply you subtract the total cost from the total revenue. That will give you the total profit. So it's gonna be 100D plus 5,000 minus 2,000D divided by D. So that's the total revenue minus the total cost, which is 3,000 plus 150D. So then you can just rearrange it. We'll get minus 50D plus 2,000 minus 2,000 by D. So that's my profit function. Now we'll have to find out the demand for which the profit is maximum. Now think about this. Let's say the y-axis is the profit and the x-axis is the demand. So assume that the relationship is something like this. It's not so smooth like this, but there will be somewhere where you have this profit highest. So at that point, as you can see, if you draw a tangent here, so the slope of this line will be 0. So slope is basically y by x or dy by dx, which you can set 0 and then solve for d. In this case, y is profit and x is d. So let's take the first derivative with respect to the demand. So d, so if we set this to 0, then it will give us the value. So if we set this 0, so that we are finding this demand for a 0 slope line, which is the horizontal parallel line, this one where the profit is maximum. So we're trying to find out this point. So this demand point for which this profit is maximum. So if we solve for D, I have found 6.3. Now you can't produce 0.3 units, so it has to be it has to be rounded to the close number, not rounded up. So it's going to be basically 6 units for which the profit is maximum. So then you put this number, plug this number into the profit equation. That will give you the maximum profit. So maximum profit is minus 50 times 6 unit plus 2,000 minus 2,000 divided by 6. So if you solve this, I found 1366.67. So that's the max profit. I think the last question was asking, how do you know this is a positive value or positive slope? So basically, you take the second derivative. If that's negative, that indicates the there is the curve look like this, not look like this. So the profit, when the second derivative is negative, that tells us that there is a positive profit making. So if we do the second derivative, that's going to be 0 plus minus 2 by d cubed. So that's a negative value. Negative value means positive slope, where we have find out that demand for which the profit is maximum. So again, this is when you don't see a relationship that's a linear relationship between price and demand. If you have the some kind of different relationship other than the linear relationship, you have to apply the basic formula. So you can't use these straight equations where many of you used in the exam.